This time on the show, Linux authentication with a Yubikey. We're talking one-time passwords and two-factor authentication for SSH, plus free SSHFS clients for Windows, relay proxies without exposing ports, and known host editing tips. All that and more this time on Hak5. This segment of Hak5 is brought to you by IdeaPaint.
Hello and welcome to Hak5. My name is Darren Kitchen.
And I'm Shenanigans.
And this is the show where we re-engineer everything because it wasn't broken.
Yeah, that seems to happen a lot whenever you do the show Hak5.
Actually, about once a year, you know?
Yeah, pretty much. Either we're doing it in a dining room, doing the show in a dining room, or a kitchen, or...
a garage.
The garage.
When I do the show in the kitchen, it gets recursive, like GNU.
You know, yeah. Remember that one when I was like chewing on popcorn behind you? I was like, what?
There's no point to it all.
WTF? What?
There's no point to Hak5. But what we're talking about here, and we'll have to get a B-roll shot of this, is we have definitely re-engineered the whole studio and gone back to a live-to-tape setup instead of recording ISOs. I know that's not why you tuned in, but we're just kind of giving you an FYI why things might seem a little weird because we're doing happy, fun, switchy stuff, and Paul's over there in the corner with a board of lights.
We do it live, sir.
And this is going to give us a whole lot of new opportunities with live. So we have to figure this out, and that means that we fly by the seat of our pants with our hair on fire, and we...
Yeah.
I'm just imagining now the seat with the fire and the pants in the sky.
Lighting my hair on fire.
All right.
Could be good times.
Let's do some techno-lusty stuff.
Yeah, let's do it.
Yes.
So what's going on this episode?
Well, as you know, we have been talking SSH lately in the context of proxies, and
yes.
We talked a little bit about security, and we went into, what was it called? Public key authentication.
Mm-hmm. Yep.
We talked about using proxies to do some little bouncing around stuff, and
yes.
forwarding, local and remote, and things like that. We're actually going a step back to password-based authentication, but then making it even cooler with one-time passwords, two-factor, and good stuff. We talked briefly about how I use a Yubikey to log into the Hak5 WordPress,
right, yeah.
and a couple of other things, and I really love it because it's just easy, it's secure. And we're going to do the same thing here for our SSH server in Linux.
Awesome, okay.
Yes. So I figured that we should go ahead and just start off by talking about like a quick recap of some of the things that we've covered before as far as SSH auth is concerned. And as you remember, there are 4 different modes of authentication in SSH. There's password, which we started with.
Right.
There's public key,
which is very secure.
Yes. And then there's also keyboard interactive.
Which we didn't really touch on.
You know, the thing about keyboard interactive is it's mostly used for one-time passwords, except in this case, we're actually going to be using password authentication for one-time password. And we'll get to how that's all going to work here in just a second. The last one being GSS API. That's standing for Generic Security Services, and it's just how you can like implement Kerberos or NTLM or crap like that. We're going back to talking about password authentication because we're going to be tying it in with a module that will allow us to use our Yubikey.
Okay.
And so to understand password-based authentication again, we need to realize that at least on the Unix side of the world, what we're talking about when we say that is we're talking about PAM.
That's the chick from The Office, right?
Yes, the chick from The Office is actually responsible for authenticating users in Linux.
She is an excellent Office administrator.
Yes. Well, PAM stands for pluggable.
Like plugging in?
Kind of. Pluggable is in like modular. You know?
Okay.
Authentication module. And this is really the default that you're going to find in Unix-like operating systems. So your Linuxes of the world and all the variants and stuff are going to use PAM to do authentication. Okay. And so this came about back in the day in response to an RFC, or a request for comment, by the Open Source Foundation. They were like, hey guys, let's talk about the way that we can make Linux more happy and open and stuff.
Sounds like it happened a long time ago.
Well, in a galaxy far, far away, Sun Microsystems was all like, hey guys, check out PAM! And then Oracle came by and was like, rawr! And then open source lawsuits, but that happened later. So The idea with this, though, is that PAM is a modular system for handling authentication. It's kind of like an API, just like GSS API allows you to integrate things like Active Directory into SSH authentication. Well, PAM allows you to integrate lots of different kinds of authentication modes into Linux, or, well, I'm going to say Linux over and over, and I really mean Unix-like operating systems. GSS API actually does Kerberos. I'm just going to write Kirby, because she's all like,
yay.
meow. But, and that's probably the only caveat that I'm going to go into. It's a rat hole, but you're not going to find Kerberos in PAM. You kind of can. It's a different story.
Okay.
The point being, this is basically what you use to log into your modern Linux systems, and there are 4 modules that go into PAM.
Okay.
And so the first module is account.
And this is like my Windows sign-on account, except for Linux.
Yeah, on Windows you've got the SAM. On Linux we get the PAM.
We have the PAM.
Oh, dude, so
Nice.
like if PAM met SAM, and then they were all like, oh, and they fell in love, and they used,
It'd be
and then they got a
perfect for each other.
Kerberos, and then anyway, we could like
Oh my
totally do
God.
some machinima later. But yeah, the account module of PAM is really just saying, okay, who are you? Do you have access to be? Are you allowed to even be accessing this system? So it's responsible for, just checking out that user.
Right.
Right. Second part of this is actually the authentication. And the authentication is what verifies the identity of that account and says, hey, it's typically using a password and saying, hey, what's your password? Is that what I have on file? Is everything all good? Right? Well, the way that it actually manages those passwords in this case is an aptly named password module.
So that's a password manager, not the same as the authentication
Yeah,
module?
authentication uses part of this to authenticate this guy over here. Right?
Okay.
And so this is, as we've seen, as we kind of dissect more and more of these, just like SSH has these different authentication types, it has those 3 different channel types. We notice that there's a lot of modularity in when you design a protocol, and that's all done for security's sake, and for lots of other reasons that are outside the scope of this discussion. But suffice it to say, these are the first 3 of the 4 modules in PAM. The password one is really cool because this, authentication handles checking the password from the account, right? What's password? Well, that actually manages the password. It is, like you said, a password manager.
Yeah.
And let's just go ahead and take a little diversion here into the fun world of /etc/passwd.
PWD.
Yeah, well, PWD prints the working directory. PassWD is the password, and people say Unix isn't
Password working directory?
Not quite. Actually, you are right in that PWD is a Python password module, but that's a totally different story. We're getting really sidetracked here. Basically, the reason that I bring this up is because PAM, as it's responsible for the passwords, is going to use this database file that you find on a typical Unix system that lives in this directory called etc, and the file is called passwd. It's just a text file. Right? And what it contains, and I'll just use my system as an example. So my system at home is going to say Darren. It's going to have a line that says Darren, and that's my username. And then there will be a colon. And so each of these different values are delimited by colons. The next thing is going to be an X, and we'll come back to that in just a second. The next thing is going to be a number. And in my case, it's actually 1,000. Right?
What is that number?
That number is the user ID number. So remember how we talked about how in Unix there are there's the user, there's the group,
Yeah.
and then there's the overworld.
So this is the ID number for your user.
Yes,
just that section.
That's my user ID number, right? I also have a group ID number, and in this case, it's also 1,000. This is my primary group ID. Well, because I am the master of my own group. Mind you, I can also belong to other groups. This is my primary group, just like Paul and you and I could all be a member of the Hak5 group. And then we could have.
So it would be something like 1001 or something like that.
They're anywhere between 0 and 32,000 something. And there's a fun trivia thing about that in 16-bit integers, but we're not going to get into that. The next thing is actually going to be the geckos.
Oh, geckos inside your computer.
Dude, Why wouldn't there be geckos in your
why
computer?
not? They're cute. Green.
This is...
They protect your passwords.
This is
with
typically...
their little hands.
Yeah, they do. That's what geckos do. I'm just imagining little... Woo! Anyway, the geckos is actually an acronym.
Okay.
For General Comprehensive Open... General Comprehensive Operating System. And this really dates back to like, I mean, we're talking Unix here. Linux is Unix.
This
Unix
is like
goes back
school.
to Bell Labs in the 60s.
Oh my God.
And computers are the size of your refrigerator, plus your mother, plus your house, and your car, and everything else. Anyway.
Okay.
So the reason I bring that up is because this here, it's a fun little trivia fact, but back in the day, Bell Labs used this area here to handle like print spooling and stuff like that. We now know it as geckos, and what it typically contains is a bunch of comma delimited information. Typically, you're going to find it's going to be like first and last name, the building and room number that you're in, because we're all in a complex here, as well as your office telephone number and other for your, your pager.
That's amazing.
Yes. So that's our geckos. I actually leave this blank all the time. I don't like to fill it in. Mine will just say comma, 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 chameleon. And then the chameleon and the gecko hang out with Sam and Pam, and then it's just a good day. And then there's also your home directory. In my case, it's /home/Darren. We'll just say DK. And then finally, the last thing is what what the first program is that runs when you log in. Now I say that instead of saying shell because this could be anything.
Oh, really?
Well, if I wanted a user as soon as they log in to get like a VNC session
yeah, this
back
could
to
be like VNC or anything like that?
Yeah, which would be great for making like a dummy terminal.
Yeah.
Mine, it's /bin/bash. Because I'm a bash user. You could use TCL, C shell, any of those others. But this right here, you're just going to find line after line after line of these guys. And you can only edit this if you're root. And I would recommend if you are going to edit it, use what is it? PWDVI, I think. PWVI. Anyway, I'll have to look that one up. There's a special Vi program just for editing this because you really don't want to F it up. But this file here, remember we were talking about user, group, and world.
Yes.
It needs to be readable by all of those guys. So remember when we were talking about like file permissions?
That's not very safe,
well,
right?
Kind of. It like back in the in the 80s and early 90s, not so much. When your file's properties is like r-r-r-r-, meaning readable by the world, the user, and the group, not necessarily in that order. Well. So for that reason, we have X. And what that refers to...
So an X means no, you can't read.
No! Yeah, or an asterisk, sometimes to disable the user. But this refers to a file that you're typically going to find on Unix systems past 1992. I think it was like 1989 or 86 when it was originally developed. But basically, as far as the Linux world is concerned, 92 and on, it became popular. And you're never going to find a system now that doesn't use this, practically speaking. We could boot up a VM just to fire up John the Ripper and show you why we do this. That X right here refers you to a file in /etc called shadow. Because before this X, what you would have typically found in here would be a hash value for the password. And what's wrong with that?
It's not salted or anything?
No, it's not at all salted. And
really?
Yeah, and so we're talking about an algorithm like SHA.
That's awesome.
Like if you've got an SHA-1 based salt up in there, or hash of your password up in there, and anyone can read this. If you go back text files.
So I could just get onto your Linux box, sign in as any user, and then check out this file in the system because I can read it as any user and find all of your information, all your passwords.
Well, you'd find the hashes for them, but then you could run them through like John the Ripper,
because they aren't salted,
which is a brute forcing program, and that's actually, if you go back to like the text files of the late 80s and early 90s on textfiles.org, you're going to find a bunch of ones that say log in as guest and download the /etc/passwd file and run through John the Ripper and then break into the system.
All right.
So that's why we have this, because what you're going to find in here is your user ID. And then some other stuff, and basically the gist of it is at least on mine, I use this thing called $6, which is a SHA, in my case, 512, and everything's encrypted in this.
Okay.
So this is a encrypted equivalent here, and this has different permissions than this readable by everyone password file there.
Okay.
Okay, so that was, I know.
So this talks to that talks to that.
Yep.
Cool.
That's the idea.
Got it.
And so Pam will use this database here to manage the password, and then, so changing the password and stuff like that.
Nice.
So those are the first three. The last, of course, remember we're talking about pluggable authentication module here. The last part of that is session. And so this module in PAM is really just responsible for managing sessions. So hey, are you logged in? Did you time out? Things like that.
Okay.
You ever run a sudo command? And
Yes.
sudo apt install something, right? And then and then it'll ask you for the password, right?
Yeah.
And then later you're all like, oh, I want to image this, so like sudo dd this thing to that thing.
It doesn't ask for your password again because you're already in there.
Yeah, it's memory. Well, this is the part of that is going to maintain your session and say, hey, if you haven't used, like, say, for example, sudo, where you're logging in, it's saying, hey, after 10 minutes, or if you open a new terminal window, it's a different session, things like that.
Okay, cool.
So the reason that I bring up all of this stuff about PAM is because what we're going to be doing is adding a module to PAM that's going to allow us to do a little bit of one-time passwords.
Yay! This sounds logically similar to my Google Authentication app, which uses a one-time password every time.
That is a perfect practical example or an implementation of that. Another being, the Yubikey from Yubiko, and we've actually
RSA
had
tokens
Stina
back
on
in the
here.
day?
Yeah, RSA tokens. If have one of those, throw it away because that's
I have
been
one.
hacked.
It's a keychain.
Really? But that's the idea, is that if you've ever used any of those, like the Google Authenticator app is a great example of one because it's time-based. And so I guess I should bring up that what these are versus your regular password is. Your regular password is static. And these are dynamic. Meaning that every time you go ahead and run your application, or you use your token or whatever it may be,
It changes every time.
It changes every time,
Yeah.
right? And it works on, the whole principle of this is based on random, who doesn't like,
Well, I hope it's random.
well, who doesn't love random numbers? And so
Yeah.
there's a bunch of different ways to come up with random numbers that both the server that's authenticating you over here, as well as you, are going to be able to come up with something that you can negotiate and everybody's going to agree upon, right?
Okay.
There's a couple of ways. You mentioned the Google Authenticator. When you open that app, it's got like a little pie chart thing that goes around.
Yeah.
And so you've got 60 seconds or something like that to type in this password. Well, that is an example of one that is time sync. So in this case, a time sync is your application on your phone is in absolute sync with the Google Authenticator on the back end, which uses Epoch Unix time. It's another tangent we can get into, but basically the time in seconds since some arbitrary date in the 60s has been incrementing, and so they both know that, and then using the time as well as a formula, they're able to come up with a value. That's the oversimplification of this. The other thing that you could do is use a previous password method. So a previous password method would look something like this. If the first time I plugged in my my Yubikey and it said 0001, the next time I plugged it in and it said 0002, you might imagine what the next password might be.
Oh, I don't know. 0003?
Probably. And if you got enough of these, you can figure it out.
That doesn't sound very brand.
Well, in this case, we're talking about the algorithm would look like this. And I'm not talking about Google here.
Yeah, +1.
Yeah.
Yep.
But this would be an example of an algorithm. Now, obviously, you'd use something a little bit more complex than +1. You'd like, multiply. You'd be like multiplied by the love for your mother and a bunch of other stuff, and then you'd get that.
Okay.
Of course, if you were able to get enough of these, you might be able to reverse it
True.
But that right
would
there.
be utterly complicated.
Yes, and that right there is previous pass.
Okay.
If you've got somebody that's collecting enough of those, you get bigger problems.
Yeah.
Actually. And then the last one would be a challenge and response.
And that would be like what?
I'm thinking like WPA. So when you
Oh, yeah.
when you authenticate with WPA, and we could do a whole Wi-Fi series with a whiteboard, that'd be fun. There's a 4-way handshake involved.
Yeah.
And nobody actually gives up what the password is in plain
Yeah.
text or anything like that. It's a bunch of math. And so that's our fun math. So this is you all using that good stuff, right?
Okay, cool.
Those are a couple of the different methods that you're going to find to create randomness for one-time passwords. And really, when we talk about one-time passwords, you know, we should keep in mind that a lot of times, all of the things that we're seeing in here, like, you know, you mentioned the RSA, secure ID tokens, Google Authenticator, your Yubikey, those are all single aspects of a greater two-factor authentication system. So here we go. I have no markers anymore. So two-factor auth. And so two-factor authentication is basically defined as something that uses 2 or more of 3 factors of authentication. Now, those 3 are, first of all,
something you have, something
yep.
you are.
Something you have. Sure, something
And
you
have
are.
could be something like your Yubikey.
And something you know. Yes, exactly. So my Yubikey is something I have.
No is the password that you have in your head or whatever.
Right. In my case, it's 1, 2, 3, 4, 5. And in your case, it's game. Right?
Yes. Well, it kind of is.
We all just lost that. And then R is, like you said, something you are. And so that's me.
Oh, so like biometric authentication.
Yeah, so like one of these. I'm
Got it.
doing a horrible fingerprint or one of these. And you're all like, I've been out all night drinking and I'm angry. Anyway, so anyway, you can actually already think of an example of one of these that you currently use probably all the time, and that is a big fat, your ATM debit card.
Oh, you're right. It's something you have and something you know, your PIN.
You've got the plastic card and you know the PIN number, which in your case is 1, 2, 3, 4, right?
Of course.
Of course. And so now that we've kind of gotten into that and talked about some of the different practical implementations, I'm going to go ahead and show you how you can implement the Yubikey into your SSH daemon on your Linux box, and by just adding a PAM module, and it's going to be so much fun. So stay tuned. We're going to get into that here in just a bit, right after a quick break. IdeaPaint transforms virtually anything you can paint into a high-performance dry erase service that erases cleanly every time, just like our very own Hak5 table right here. Look, it's the cloud. And get this, with IdeaPaint, you're empowered, just like we are, to collaborate, to interact, and to fully explore your creativity, and in our case, our technical wit. Get that. So no matter where you use IdeaPaint, big ideas are sure to follow, and it's one of the most flexible, durable, and cost-effective dry erase solutions on the market. So go ahead and head over to ideapaint.com/Hak5 and learn more.